How does taphonomy bias the fossil record? Imagine trying to put together a puzzle where some pieces are missing or damaged. That's similar to what happens with fossils because of taphonomy. Taphonomy is the study of what happens to an organism from the moment it dies until it becomes a fossil. It's like a filter that affects what parts of ancient life we can find today. This process introduces biases that shape the fossil record, making it incomplete and uneven. First, think about the body itself. Hard parts like bones, teeth, and shells are much more likely to survive the journey to becoming a fossil. Soft tissues like skin, muscles, or internal organs tend to decay quickly and rarely fossilize. So, the fossil record is mostly made up of creatures with sturdy skeletons, leaving out many soft-bodied organisms. This skews our view of past life because we see mostly the durable parts. Next, environmental conditions play a big role. If an organism dies in a place where it can be buried quickly, like a river delta, lake, or ocean floor, it has a better chance of becoming a fossil. But if it dies in open land where scavengers and weather can break it apart, it usually disintegrates before fossilization. This means fossils are more common in aquatic or sediment-rich environments, biasing our understanding of where ancient life thrived. Post-burial processes also matter. Chemical changes in the ground, called diagenesis, can dissolve or distort fossils over time. Sometimes fossils get crushed or deformed by geological forces, making them harder to identify. These changes can erase or alter important details, limiting what we can learn. Then there are processes like scavenging, trampling, or transportation. These actions can break apart remains or scatter bones from their original location. As a result, fossils often come in incomplete pieces or disarticulated bones, making it difficult to reconstruct the full organism or its behavior. Time also adds bias. Fossils from different periods can accumulate in a single place, mixing species that didn't live at the same time. This is called time averaging and can confuse the picture of how species evolved or interacted. When it comes to human ancestors, these biases are even more noticeable. Small bones and tiny evidence of behaviors like gathering plants are less likely to fossilize than large bones from big animals. This means we might underestimate how often early humans used plants or small animals. Also, distinguishing human activity from that of predators or scavengers can be tricky because bones often show similar marks. Understanding these taphonomic biases helps paleoanthropologists interpret fossils more accurately. By studying how decay and burial work today, scientists can better judge which fossils are true representations of past life and which are shaped by preservation processes. This way, they can piece together clearer stories about human evolution and ancient environments, despite the gaps in the fossil record.